Okay guys, so for the AI, I'm going to have a little intro here to discuss the system that we're going to design because it's more complex than anything we've done up until this point. So now we have currently you should be at the point where you have an AI character that will walk around the level to various waypoints. That's not very interesting. We need to add something that's a little more interactive to that. So this week we're going to create the rules for chasing the player. So we're going to keep this patrol state that we made last week, and we're going to add a pursue state to that same machine. But we're going to create some extra objects that are going to that are going to lay the groundwork for when do I pursue versus when do I patrol. And we're going to do it with specialized game objects that are going to only have a single FSM on them, and they have one job to do. All right. So the way this is going to work is you have your nav agent currently, okay? Your nav agent uh, is the top level character for your AI. So that's the top of the hierarchy for your character, and that is going to have the patrol movement machine on it, okay? Underneath the nav agent, we're going to create another object, and we'll call that a bool test, and we'll give that an FSM. Inside the FSM of the bool test, you're going to have you're basically going is what it's going to do is it's going to take three Boolean values and it's going to test to see if all three of them are true. And if all three of them are true, it's going to send an event up the hierarchy to your nav agent and say go from patrol to pursue. And while it's pursuing, if one of these events, one of these conditions becomes false, it will switch back to patrol. Okay? So underneath the bool test, you're going to have three dedicated game objects that will each handle one of these conditions. So the first condition that we're going to have is going to be the rangefinder, okay? So this will be the rule for range. And there's a little illustration illustrating the basic idea of it. So we have an AI here, we have a player here, and this is the player further away. So the green check is just basically saying, hey, we're just going to check the distance of the AI to the player. When it's within a certain threshold, say true. All right. So when the rangefinder says, okay, the player's in range, set the bool for this up here to true. The second rule we have is the cone of vision. So this is just basically testing to see whether the player is in front of the AI or is it behind the AI, or is it off to the side, but is it off to the side enough to be seen, or is it too far behind to the side to not be seen? So this little cone right here is just sort of an indication of the field of view of the AI. If the player is within a certain value and in front of it, uh, cool, I can be seen. Let's go up to the bool test and we'll say the rule currently is true. If not, it's false. And don't worry, this is a lot easier to do. This isn't too terribly hard to figure out. Um, then there's the rule for visibility. So a player can be in range, it can be within the cone of vision, but it can also be invisible. So like if it's behind a wall or some other structure or something like that, or if it's around the corner, right? If something can be around the corner and isn't visible. So this kind of illustrates this exact scenario right here that this rule tests for, where the player is in the cone of vision, the player is within the distance, but there's a wall between the player and the AI, so he's not visible. So that rule is set to false. This over here it would be, there's no wall. I mean, granted, the AI is not facing that way right now currently, but we'll just imagine that, if he were facing this way, then yes, he would meet all those conditions. So we're going to make uh, very specialized systems that aren't very complex in themselves, but they work together and they send information to other systems, and that creates the appearance of a much more complex behavior. Now, this isn't necessarily the way you would do AI. This is a way to doing it for teaching you guys these principles, but I think you'll find that this actually works out pretty well. Okay, so this is the scene with the waypoints, and Grunk here will walk between all the waypoints. Um, let's add let's go ahead and add up our new functionality to it. So here we have the system as it exists, where it finds a waypoint and walks to it and then gets another waypoint. Let's go ahead and add a new state for patrol, or sorry, pursue. And we need to have some new transition events, some global transition events, because we want to make it so that within this one state machine, we can transition between patrol and pursue. So I'm going to make an event called chase, make it a global event, and add global transition, chase. So this icon up here where it's a solid block with an arrow down, that means it's a global transition, like the start is a global transition. Okay, so now we need another event for patrol. And patrol is a global event. Add global transition, patrol. So when patrol gets sent, it will start out at find a waypoint, not walk to a waypoint. So I'm going to leave pursue empty for now. I'm not going to add that functionality just yet. Actually, why not? All right, so the heart of pursue is we want to get the player's position and move to the player's position. So in our waypoint, we're getting the position of a waypoint and we're moving the NPC to that point. So instead of getting a waypoint, we want to get the player. So this should be familiar. Finding a game object. This should be easy if I can spell. With tag player and a new variable player. We want to find the position of the player. I'm just going to go kind of fast. You guys should be comfortable with finding actions and making actions right now by this point. Alright, so we're getting the position of the player. We're going to store it in a new variable, a vector, call it player position. And we want it for every frame. And we want to set the agent destination, so I'll just copy that action and paste it here. The destination is going to be the player position. We don't want a path pending done event. Alright. So that won't work currently because we're not sending anything to this chase event. So let's get started on that. So on the top level of my player, I'm going to right click, create empty, which just creates an empty game object in the hierarchy. And if we remember from the intro, we've got 3 different tasks to do, but we're going to manage the result of all 3 of those tasks with one object. So you basically will have 3 subordinates reporting to a manager is one way to think of it. All right. So let's make the manager first. All right. I'll call this the bool test, and we'll add an FSM. Okay. So one thing that I know is that this bool test is actually going to also report to the CEO, would be the grunk. All right. So let's get the parent. All right, so we get its parent, and we store it in a new variable. We'll call it parent. Add a transition, add a state. Okay, so in here, this is where we do our test. And we need 3 booleans to do our test. So let's go to the variables tab, go to bool. We want to know if it's in range. We want to know if it's in cone, so if it's in the within the FOV, and we want to know if it's visible, is visible. So I've got 3 Boolean variables. I've got in cone, in range, and is visible. And on the actual state itself, I want to test if all of these are true. So if I search on bool in the actions window, there is an all true. Okay, this is what we want. The number of bool variables is 3. We're testing to see if 3 are true. And then go ahead and fill this in with the 3 we made. So in cone, in range, is visible. All right, and we want to do this every single frame. So let's add another state. Okay, so once those are all true, we need to send an event to the CEO, to the grunk, the top level of grunk, to chase, because he can see the player. So let's see, let's call that send chase. Send event, new event. The player is seen. Click to add. All right. So the next thing we want to do is we want to send an event. I think that's it. To game object FSM, right? And we want to send it to the parent. And the name of the FSM we want to send it to is AI movement FSM. So let's just copy the name of this FSM. And the event we want to send is pursue, I believe is what we called it. No, we called it chase. So I've got another event called pursue from something else. So I want to make sure I get that right. So let's go back and make sure that we set it to chase. You probably won't have that problem. But make sure you're sending the right event. And you don't need to send that every frame. Okay. So I've got this set up now in this bool test to send an event once all 3 of these conditions have been met. Now I haven't gone through and I haven't actually set up the rules for how these rules get set, but I need to have a way to get from chasing the player to going back to patrol. So let's go back to bool and see if we can find something that will help us. So let's see. I can do 3 bool tests. Why don't I do that? I'll do 3 bool tests. Give me another all true. I don't need an all true. I just need a test. You could probably do this with a bool changed, but that just thinking in my head, that seems like it might be unreliable. I want to make sure like I'll just do a bool test because I know that will be reliable. We want to do these on every frame, and we want to test each of these individually. So in cone, in range, and is visible. So, and we want to test if these are false. So if any of these become false while we're in the send chase, we want to go back to the test and go back to him patrolling the waypoints. So is false, new event, back to patrol. And these all can get filled in with that. So is false, if any of these go false, we go back to patrol. So now we also need to have the event. So let's copy this action. It's got the address for where we send the event. Let's put this at the top. And instead of chase, we want to send patrol. And it will go ahead and it will send this event when it comes out of the initialize. All right. So we can't test this yet. So hopefully this is set up and it's working well. I don't see anything in here that leads me to believe it won't. Oh, one more thing is for debugging, let's go ahead and on all of these bools, let's go ahead and make sure that these are in the inspector so we can see them while we're testing. All right, let's make sure encode in range. Oh, I've doubled up on in range is visible. Encode in range is visible. Okay. Yeah, cool. They're all being used the same number of times. All right. Okay, so underneath the bool, which is the manager, we want to create the little worker machines. So let's create an empty for, this is the visibility test, or the distance, the range test. All right, I'm going to copy that state, the initial state from the bool test FSM, go to the range test, paste the state, yes, replace the start state. Okay, so in this state, we're getting the parent, which I know we're going to need, and we're storing it in a variable called parent. We're also going to need the player, because remember, this is to check the distance between the NPC and the player. So let's find a game object, tagged player, store new variable player. And this is distance or range test. And search on, I think get distance. There's a get distance. So the game object is get between the owner, oops, and the player. We'll store it as distance to player every frame. Now I'm going to go back up to the grunk at the top level and show you that that's basically what we're setting up. Is we're setting up something very similar to what we have here to determine whether to get a new waypoint or not, right? So if we determine getting a new waypoint by checking the distance of the agent to a threshold of how much distance is between where the agent's at and the waypoint it's walking to. We're going to do something very similar for this range test. So we've got a distance now of the AI to the player. Now we need to test and see, is that near, at what point does it need, it's like, okay, well I have a distance, but when do I do something? How close or how far away do they need to be before I take action? So let's do a float compare. The first float will be the distance to player. And let's make another variable. Let's make a float called max distance. We'll expose that to the inspector so we can edit it there if we want to. And let's give it a default value of, I'll say 15. So 15 units away. So if the distance to the player is, now we got a side here, let's give it a little bit of a tolerance, give it like a 0.2. So if the distance to the player is less than the max distance, we want to do something. We don't want to do if it's greater, right? We want to check this every frame, so make sure that's checked. So if the max distance, or if the distance to the player is less than the max distance, we want to send a new event, and that is in range. Click to add, make a new state. All right. Now, what we want to do here is we want to set this in range bool to true once this condition has been met. So when we transition from the test to here, call that range true, we want to set an FSM bool. So we want to set FSM bool, the game object we want, oops, we want to specify the game object. It's the parent of this current object. So specify parent. That's why we're getting the parent here in the initial state, because we're going to use that here. And the FSM name that we're going to set, you want to get the name. This is just set to FSM. Let's call it bool test FSM. Just naming things FSM is technically, I guess we could get away with it, but it seems sloppy to me, and there's potential for error when you name multiple same objects the same exact thing, and you're relying on, finding parent to set that. So back on the range test, and I just copied the name after I renamed it, and I paste it, and the variable name is in range. So let's double check that. Let's make sure I've actually got the variable name right. Yep, in range, lowercase I, capital R. So make sure your naming convention is consistent so that you get those things right. And the value we want to set is true, right? That's what that checkbox means. That's setting it to false, that's setting it to true. So let's look at this here. Okay, so we've got this get distance, all right? So now this tests if it's true and it sets it, okay, if we're within the right range. Now we also want to be able to detect if the player is no longer in range and then set it back to false. So let's copy these actions. Just select them like that, just clicking on the text and press Control C. Go back to the range true state, Control V. So instead of if it's less than right here, so we're getting the distance between the player and the game object itself, which is underneath the AI, and we're storing it. And now instead of less than, we want if it's greater than the max distance, okay? New event, out of range. Add every frame. There we go. Okay, so now I'm checking here. We're getting the distance. We're storing it. If it's greater than the max distance, we're out of range. And we go back. Now, I'm not setting the bool back to false here. So let's copy this state, and paste it, and move that to the top. So that gets done right away. All right, let's do a quick test here. So I'm going to select the bool test object here, and I'm looking at this stuff right here. So hopefully, when I get within range, that will go from false to true. Yep, there it is, it's true. Backing out, backing out. Does it change back? It does not. Okay, need to figure out why. Gonna pause real fast. Storing every frame, we're comparing. It's less than. So when it transitions back, it sets the value automatically to true. So I forgot to uncheck that box, and that's why it does that. So let's check and see what happens here. It's a common mistake when you're copying and pasting actions. All right, it's currently true. Back out false. Get closer, true, false. All right. First one down. Okay, now we want to do the cone of vision. So once again, on the bool test, right click, create empty. I almost go right by it. Cone of vision. We want to add a Playmaker FSM. Just call that cone FSM. All right, so I'm actually going to copy this initialized state from the range test and paste it in the cone of vision. Yes, replace the start state, because it's getting some stuff that we're going to need over and over again. Okay, so now to test for the cone of vision, this gets a little trickier. We got to think about 3D space. All right, so the first one, we just had to think about a linear distance, right? How far away is the player from the AI? What we have to think about now is we have to think about what's the angle between the player and the AI, okay? And what does that even mean? So angle test, not angel test. Let's go in here and let's just search. Here we go. Get angle to target. Gets the angle between a game object's forward axis and a target. Okay. So in Unity, there is a global understanding of the concept of forward, which is basically just 1 on the z-axis in local space. So this little blue arrow is forward, and that's the cone of vision right here. I'm going to go ahead and I'm just going to move the cone of vision object up a little bit in Grunk to like his head. That's kind of where it's supposed to be, in my opinion, or where I kind of imagine it. So back in our FSM, we have the game object, which is the cone of vision, the target object, which is the player, and then we have a target position. We're ignoring height, and we're doing it every frame. Angle to target, target object, every frame. I think we should be getting and storing this as a float as well. Oh, yes, here it is, store angle, I'm sorry. New variable, let's see. We'll call that angle to player. All right. So we're getting an angle to the player here, and let's go ahead and put that variable in the inspector. Hit play, and we'll look at the variable while we're playing and running around here and see what we get. Okay, so when I'm behind him, I get close to 180 degrees, right? It's a little bit off, but it's back there, right? I get up to him towards the side, starts approaching 90 degrees, right? Start to make a right triangle. So if you imagine that we're walking forward here, a line coming straight out from Grunk and my position, you can sort of imagine the triangle that gets built. So as I move around him here to the front, right, I have to decide, like, what do I want, where would I want him to be able to detect a player? Do I want him to detect a player from behind him or right beside him, right? Like 90 degrees? Or a little bit behind him, give him a little bit of extra perception? Or do I want to be really narrow and like right in front of him? So I'm kind of walking around here and I'm looking at these values as I'm doing this, getting an idea of like when do I want to be able to detect. So I'm thinking, let's go with like 135 degrees so he can see a little bit behind him. Not realistic, but a little more challenging. So in order to get him to react to the player being at 135 degrees or under, we need to do another float compare, because that angle is getting stored as a float. All right, let's make a new variable too. Let's make another float. We'll call that the max angle. We want the floats be angle to player and max angle. If it's less than the max angle, new event, in cone. And we want to compare every frame. So I'm actually going to just copy this state because we're going to need to do the same stuff in here that we're going to do in the next one. In fact, let's be really efficient. All right, so here we've got this range test right here. We've got the set FSM bool action. I'm going to copy that, go down to the cone of vision, paste it, put it at the top. Instead of in range, I want in cone. Okay, because we're setting a different different bool. And then I'm just going to copy this entire state, paste it. We want to reverse the bool value, so when it transitions, because it's inside, right? So we're checking to see if the angle is less than, and when it is, we change from this state to this state. We want to then turn the bool on. All right. Then we want to test again. We're going to keep running our test. Make sure that that if we get outside, if we get over the max angle, right? So if we go from less than to greater than, we're out of the cone. And then we go back. And we can remove this event, so we don't need that. Okay. And that's called angle test 2. That's not good. Just name it something else. Named it test for out of cone. All right. Now let's check and watch and see if our cone of vision works. Okay. So if this works, we should be able to see our in range go from false to true and out back and forth depending if we're close enough. And the in cone should also go from true to false depending on if we're within his visible cone or not. So right now, not. Okay. The cone of vision is not working. Let's pause. Select the cone of vision. Let's take a look. I didn't set anything to the max angle. I just made the variable without giving it a value. All right, my bad. Put that in the inspector. And I think I said the max angle was like 135. Okay, so that's set. Let's look at the bool test now. And play, and hopefully it'll work this time. Okay, yep, both true. In range, still true, 15, okay, false. In cone, so wow, he can see me from there, but I'm not within range. He doesn't care about me. Okay, now he would care about me at that point. Okay, I'm feeling like in the range on that's a little long, but whatever, we'll deal with it. Okay. One more to set up. Okay, so let's get the visibility test. So make one more empty. Add the FSM. All right, and once again, let's just copy this initial state. Yes. Now, let's see here. This is going to be the visibility test. So we have to use a new action that you guys aren't familiar with to make this work. We got to use something called the ray action. And what this does is it sends a ray, or the raycast, it draws a ray from one game object to another. Or just it draws it out. It'll either like draw it out in space for, down its forward axis, or any other axis you define, or any other direction you define. I mean, there's a lot of options here. So we're gonna draw a ray from the game object, from the owner, in a direction. We're going to see where it says direction. We're going to uncheck that. We're not going to feed that with a variable. Oops. We're going to put 1 in Z, so basically it's going to send a ray down where this is at, and right now it's at his feet. I'm going to move this up again. There we go. Okay. And turn on debug. So when I hit play here, you'll see that there's a ray, a yellow line coming out of his head. See that? Oops. Let's, where's Grunk at? All right, here we go. You see this line coming out of Grunk? All right. So that's the ray that's shooting out, okay? And if we go back to here on the visibility test, the result here, these are all the things that you can do with that ray hit. So there's a hit event, so like if the ray hits anything, you can send an event. You can store if it did hit, you can store what was hit, you can store the point that was hit, you can store the normal, which is the direction of the surface that gets hit. You can store the distance too, so how far away was what got hit. So what we want is we want to store the object that gets hit. Okay, so if we imagine for a minute that the girl gets hit, okay, by the ray, we want to store whether it hit her or if she's over here, it hit the wall. But in order to do that first, we need to make it look at her, okay? So let's do that. Let's make sure we get it looking in the right direction, because right now it's not doing that. So open up the action browser and just type look. Oh, there's an action for that. Look at. Do that before the raycast. The target object is the player, which we already have because we copy that state and save ourselves some time. All right, I don't think we need any of that other stuff there. We'll do that every frame. So now when I hit play, hopefully, yep, you see that line? All right, pause it. That line is drawing towards the player. I'm going to actually move the look at the visibility test, move that a little bit lower. That's pretty high up. All right. So we want to store the hit object. Okay. So how do we know what was hit? Because we want it to do something different if it hits her versus like the wall, right? So if she's over here and the ray goes through her, we want to be able to know like, hey, look, that's a wall. Don't count that. What we can do is we can actually compare the tags of the object hit to the tag of the player. And that's how we're going to do this. game object compare tag, which is here under logic. We're going to compare the object hit with the tag player. Okay. So if the tag compares to player, we want to send an event. New event, player hit. And we want to do this comparison every frame. So once again, we're also going to want to set a bool. So let's go up to this cone of vision here, and let's grab the bool, the set FSM bool with the proper address, but the improper variable name, and paste that, send that to the top, move action to top. We want to set the value to false, and we want to say is visible. I believe that's the name of it. Let me check here. Excuse me. Excuse me. Is visible. Yes, that's correct. All right, so yes, bool test FSM is visible. There we go. Okay, so just copy and paste. And we want to set that to true. And we want to compare, we want to send now if the event is false. Not player. So we just kind of change that out. So we still want to test while the player's hit. So if the player goes around the corner while Grunk's pursuing, he'll like, oh, player's gone. Now that's not necessarily the best behavior, but programming a more complex behavior for that would be perhaps a little bit much for this lesson. If you want to, if you get done with this early, you should totally set it up so that Grunk will continue to the last known good position of the player before going back to the patrol. I'll make that an extra credit for some of you that are missing points from late turn-ins. All right. So just look over this real quick. It's doing the look at. Okay, does everything that we should. Okay. Let's look at the bool test now while we play this back. Okay, so it's in the cone, not in the cone. In range. Okay. It's not doing the visibility check. Okay, there it did. Oh, hey, look, he tries to find her or something. He did something, he changed his behavior. Okay, there's something not working out too well right here. Ah, look at that. He goes back to patrolling. Went around the corner. He thinks he sees me. Alright. There's some funky behavior there. So let's take a quick look and see what's causing that. And then we'll get on to optimization because this raycast is an extremely expensive thing to do, and we don't want to do that until there's an absolute need to do it. So let's figure out what's going on first with our all right. Look at the player. Look at the player. Let's give it an up vector of y1. Let's see if that helps it. Let's drop in our tag for some reason that I don't understand. Should return the right option. Oh. So he's doing something that registers her height. That's going over her head, so let's see here. Okay, yeah, so you see it's missing her head a little bit there. And I jump and it hits, and it's like, okay, cool, all right, let's see what's going on there. You may not have this problem. This may be something specific to the model I'm using, but it's working. This is pretty good. Let's watch the state machine from the top level with the whole chase and patrol thing. See how that works. All right, so he's doing the walk to a waypoint. Boom, he's pursuing. Where is he? Why does he stop like that? There he goes. This is nav mesh. All right, I'm going to fix some of these bugs, and then I will be right back. Okay, I got some better behavior. So I did two things. Number one, I moved the visibility test from up here down to like the middle of him. And that resulted in the ray more reliably hitting the character in the middle section. The look at I was hoping would maybe if I uncheck keep vertical, maybe that will work better. Let's check that out real fast. That just shoots at the feet, which isn't any better. All right, yeah, so I would leave the keep vertical checked. On those. And the other thing I did was I reduced the cone of vision from 135 to 120, and that resulted in a more stable behavior. Oh, that's still up really high. Move that down to about his midsection so that it would hit her looking at it from a two-dimensional. Yeah, see, like that. Back to the Boole test, take a look. Saying that there's no obstructions, which is true. He's just not in the cone. Get in the cone, he starts to move after her. And he loses her. Sometimes it gets a little unstable. All right. So one thing we want to do is I'm not that behavior is not I'm not entirely happy with that, but I want to move on to the optimization part here. So this visibility test, that firing the ray, that's a pretty intensive CPU action. It's not the most intense thing in the world, but you typically only want to do those things when you absolutely have to. So since we have this scenario with our bool test where all three of these things have to be true in order to send the event to go from patrol to chase, I can actually set up a check on the visibility test to not fire the ray until the other two bools are true. So we're going to listen for those other two being true. And the way we're going to do that is we're going to get the FSM values of these two bools from here. So this this set FSM bool, we want to do a get FSM bool. I'm just going to copy the FSM name from here. Go back to the visibility test. Action browser, please. Get FSM bool. Do two of these every frame. FSM bool in range. Oops. In cone. And then we will store these in new variables, named the same thing as the variables we're getting. And then just like we do on the bool test up here, we're going to do a bool all true on the visibility test. Two values, in cone, in range, send event, new event, cast ray. Click to add, drag it, and do that every frame. So every frame it will get this waiting to see if it needs to cast. So instead of going back from not the player, we're going to go back to the listen here. So instead of going directly back to the visibility, we're going to go back to this. And in fact, we're going to add this safety check to all of the states in this machine so that if at any point in time the cone of vision or the range test as false, we can back out of the raycast. Now it's not going to be too heavy for just having one AI in the scene, but if you have a dozen or 5 or 6 AIs running around, these raycasts will add up. And you want to be able to save CPU overhead wherever you can. So let's go ahead and paste these in at the bottom. Click to add that. Bool all true. Actually, we want to do something besides an all true. So we're adding these FSM bools. Let's add a bool test, like we did the other ones. Send those to the bottom. Make sure these are at the bottom. Do them every frame. So we're still getting the FSM bools. In cone, in range. If it's false, let's remove that cast ray. We'll make a new transition. So if it goes to false, new event, back to listen. Same for the other one. So we're testing both of the other two bools, right? That's why we have one for each. We have to get each one and test each one. So copy that and do paste after. Paste actions after. Click to add, back to listen. All right. So there's multiple ways for it to get back. And this should, when I press start, we should start out with not having the ray. Yep, there's no ray. Only when I get to a point. Uh-oh. Uh-oh, I broke it. Not firing the ray, okay. Why? Those are all true. 1 second, now I'll figure it out. Let's see. We're getting the bools in cone, in range, testing them. Make sure those are the names of the variables. In cone, in range, yep. In cone, in range. Every frame. Send event to the visibility test. That should work. Okay, false. Ah, I see the problem. Whoops. So the game object is getting the owner. All right, that doesn't work. What we want to get is we want to get the parent. So for all of these get FSM bools, got to go back and set it to parent since I didn't catch it the first time. That sucks. All right. Get FSM from the parent. Parent, 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 parent. Check it out. All true. Yep, there it goes. It draws the line. I get out, it doesn't draw the line. That's optimized. So it only draws that line when it makes sense to draw that line. And you can see he's chasing me around a little bit more reliably now. Not sure why it was bugging out like that. So there you go. Some decently simple pathfinding. That's sad that he just stops like that. I'll see if I can figure out why that's going on, guys. All right, so that is setting up the chase, and I will look into figuring out that bug. I didn't encounter that when I did my test run for making this curriculum, and it showed up during the demo, so I'll see if I can figure out what's different there. So yeah, once again, if you get through this and you got your character working up to this level, um, see if you can figure out a way to make him when he loses, if one of these three values goes wrong, to go to the last known position before he goes back to uh, running his patrolling his waypoints. That would be pretty cool. I'll give you extra credit for that. Some of you guys will definitely want that. All right.